everyone's back as we continue building this project on breadboards alongside the 7th and 8th grade students in Robeson County, North Carolina. So, Jordan, Jess, Jide, and Jenna, whoa y'all, all J's. Why don't y'all get everyone caught up on where we left off last week and then what we're gonna get going on today. And just so y'all know, we are using a different link for instructions, and so Britt or Jordan, if y'all don't mind popping that link in the chat so that everyone can see it. And if y'all can just, if it's anyone's first time using GitHub as well, if y'all can just walk through how to navigate the instructions there as well, that'd be awesome.
Sending the link out right now. And Britt actually sent it out before I could.
Go, Britt.
So that is good to go.
Awesome.
Awesome. Well, with that, I can summarize what we did last week. Last week, we were finishing Kit 1 and the instructions on Kit 1. We got to the final step, which was testing it. And Jenna took a look at the board right after the stream and realized one of the wires was loose on the power cable. Yeah. But that happens. That's why we test. So Jenna, I think you wanted to proceed today with just finishing testing Kit 1 and showing how it works.
Y'all, it's one of those moments where, as I'm, watching the cameras, watching where everything is over here, I just had totally not looked and seen that these were unplugged over here. And I was like, oh no. So that was a total fail. Jide, Jess, have y'all ever done anything like that? Probably not.
I think, well, definitely for me, I have. At least speaking for myself, that's why you test as you go, because things get bumped and bruised, and you gotta make sure they're still okay as you go.
Totally. Awesome. Well, let's do it.
Cool. Well, if you want to give a shot at plugging it in, Jenna.
Yes, and actually, Jordan, can you quickly, just in case it's anyone's first time logging into GitHub or looking at GitHub, can you kind of explain how the instructions are laid up here?
Yeah, GitHub is a site that's used for revision control for software. So as you make changes or as multiple people are working on software simultaneously, it's used for keeping track of those changes and keeping everyone in sync as they all work on something together. We moved the instructions there as part of just transitioning to Kit 2. So if you click the link that Britt or I provided in chat, it'll take you to the website, and you can scroll down and you'll see the instructions nicer formatted than they were in the Google Doc, because Jess did this kit. And you'll be able to see everything there. But you shouldn't need to log in or anything to see them. You should be able to just go to the website and scroll. So no need to sign up. Just go ahead and scroll through the instructions just like you guys were doing on the Google Doc.
Yes. Awesome.
And Jess will be joining us shortly. She's dealing with a last minute, I think, vet call for one of her dogs.
Oh no.
So she'll be joining shortly, but I will be live until then.
Awesome. And y'all, I'm over here posting on our social media as well. I'm like, we're live.
All good. Well, what we finished up on Friday was finishing all the logic block wiring, and we're getting into the final test of making sure that the LED behaves correctly.
Oh, Jordan, Jess is here. She just messaged on Discord saying she's here, so I don't know if she's maybe in the waiting room.
I just promoted her to panelist.
Awesome.
Hello.
Jess! And Jide, I apologize. We have the wrong overlay on here. That does not have your name on it. I'm so sorry. I apologize. I don't know how we missed that. Sorry about that.
No worries. Let's keep moving.
Let's go.
Awesome. And as we jump into Kit 2, I think, Jide, we volunteered you for Kit 3.
Yeah.
So the bar for instruction quality keeps going up because it started as low as it could with me, and then just took it to the next level. So take a look at Kit 2 instructions and see if you're ready for Kit 3 to take off. But Jess did a really good job with Kit 2.
Yeah, absolutely. I used her instructions as well over the weekend, so it's good stuff.
Awesome.
Awesome. Well, let's wrap up kit 1 here. Jen, I think the final step you need to do is just plug it in.
Okay.
See what happens here.
Let's see. Oh, yay! There we go.
So there you go. So that looks like it's in blinking mode. So that's actually being controlled by the first clock we built, and which is the clock on the left, which is providing a very stable frequency. That frequency will be how quick the computer runs. So modern computers are in the gigahertz, or a lot of cycles every second. This is at like what, 2 or 3 cycles a second. So our computer is going to be a little slower.
But can't we?
But we can speed it up. I recommend using the screwdriver to do so.
Let's see. Or let me get this.
Jenna's here going to adjust that potentiometer that is on clock 1, and as she adjusts it, the LED blinking frequency should change. You see it speeding up there. So now we've gone forward a couple decades. It may actually go so fast we can't see it blink on the screen.
And now so slow.
Put it back down.
That's as slow as it goes.
Yeah, so that'll be really helpful for debugging or really trying to push the performance of this computer once it's live by increasing the clock speed and adjusting that. But that'll control the whole computer, so every part of the computer will be hooked up to that clock circuit in one way or another. Jenna, the next thing we wanted to test is the manual mode. So you'll actually trigger the manual mode by changing that toggle switch. Let's put the switch on clock 3 to the other position. In doing so, everything will stop unless you hit the push button. So go ahead and hit the button, and you should get blink from light and let go, and you should get a nice, consistent clock signal there. So that will be for when we're really having to debug on later elements. That will be very helpful, and Jenna is having a lot of fun.
I know.
The button
I'm just doing my best Vanna White,
Amazing.
Or actually, no, I kind of feel like, did y'all watch, what was it? It was on in the morning, and they would spin the wheel in the Showcase Showdown, and it's like, you could win a new car. No, y'all know Drew Carey was the Price is Right. I feel like I'm on The Price is Right, and I'm about to have a hot tub and be like, here's the hot tub. You could win a jet ski.
Amazing. Well, this is a 8-bit computer clock.
That's right. How cool is this? Oh, wait.
Amazing.
Oh, here we go. We got unplugged again. I was like, oh no, it doesn't work. We got unplugged again. All right. Anyway, I think we're good. Is this one good to go?
Yeah, this is it for kit 1. So go ahead and unplug that, and we'll place kit 1 to the side.
And y'all, congratulations. Finished building kit 1.
Yeah,
Yay.
That was awesome.
That's exciting. Hey, our little astronaut pin, Jide, Jess, just so you know, we have some more pins coming in. We actually are sending some of these, we're sending these to y'all students in Robeson County. They're just little enamel pins. Are those still cool? I think they're cool. Do y'all think these are cool? No? Nobody thinks they're cool?
We do.
Okay.
We do think they're cool.
Awesome.
Well, now we're going to start with kit 2. Perhaps we can introduce the components really quick for everyone who's going to be watching.
Great idea.
Jenna, you have them all there, and then we'll go forward with perhaps Jess leading as she wrote the instructions, but Jide, being that you completed the project as well, it would be helpful to have you jump in as well as we work through kit 2.
Yeah, why don't y'all talk me through the parts, and I'll make sure to show them over here in a close-up view.
Yeah, so we're gonna have a breadboard like before. Actually, we're gonna have 3 of them because we're gonna make 3 different registers, all 8-bit registers. And so what goes into that is 2 4-bit little register chips, and then 1 8-bit bus per board. So we should have like 3 8-bit bus little IC chips, and then 6 of the 4-bit register ICs, and then a bunch of LEDs. So like 8 LEDs per board. So that would be 8 times 30, 24 LEDs.
Whoa. Oh,
so
the dog baby. Jess, is everything okay?
Yeah, sorry. I was late because I had to get off the phone with the vet. No, she's fine. She just had a vaccine.
Oh, what a sweet baby.
Well, Jenna's showing on the screen there now as well. All of the LEDs. She just had the what Jess was referring to as the ICs, or the integrated circuits, there as well, which will be the chips we're using. And then I think that the only other thing on this one is a bunch of resistors. There's a huge pile of them there, and one for each of the LEDs to make sure we don't let the magic.
And then there's something else that if y'all, this might be new to some people who are learning with me. So in this kit, you're also sent the rogue wires. So Jordan, do you want to who wants to talk through how to strip a wire?
Yeah, so the wires are fun. In that, like, before, we were talking about making the wires like the perfect length.
Yeah.
So now you can actually cut it to the perfect length and then strip it with the wire stripper. So you kind of have to line it up in the wire stripper so that it's in the right spot, and then you like pull. It's hard to explain actually without showing.
Well, I don't know why this is blurry. Let's see. There we go. Okay. But essentially, like, these are just and I believe these are the wire strippers that we sent to the students, right, Jordan?
Yeah, we sent a pack of those over. We're going to be using these, which are slightly less fancy than the one that Jess has. I found them much more economical. So we'll be using these to actually strip the wires.
And so basically what you'll do is you determine what length you need. You use this. Let me get my tweezers. And keep in mind, y'all, these are all things, I'm making sure to tell y'all these things because these are things that I have been learning. I'm like, I've actually never stripped a wire before. So you cut it from the roll, right, using this part of the wire stripper right here. And then you look at these numbers here. And do y'all know which number we need to be looking for these?
It's towards the top. You can see, let's try to get them back in focus. One side is for stranded wire, I believe is the right. It says AWGSTR, which is stranded, but this is solid wire. So you're going to want to be looking at the numbers on the left-hand side. And then I think this is gauge, it's either 22 or 24. The smaller the gauge, so the smaller the gauge, or the smaller the physical size of the wire, the smaller the gauge. So
okay.
We have a pretty small wire, so it's either like the 24 or the 22 there.
Okay.
Maybe try the 24 is what I'd recommend.
I'll do this close view so y'all can really see. So you'll use this part to cut. And then, let's see y'all. Oh y'all, I'm gonna need my glasses. Oh, we need to send these. Jide was requesting some of these. Jide, were you able to get through the project without your handy dandy glasses? Sorry about that. Ah. Britt says tweezies. Britt thinks that we should have a tweezer line called Tweezies. How funny would that be?
I echo that. I think it's similar to Yeezys, but Tweezies.
People are going to line up to get their Tweezies. Limited edition Tweezies. I can't.
Yeah, Britt's actually wearing her Yeezys right now.
Am I doing this correctly?
She was joking. Sorry. You are. So
I can't see that far, y'all.
Yeah, you'll want just enough length past the wire strippers there so that you can use it.
Does that look about right?
That looks about right. And then just squeeze and pull it.
Oh, God. Did it work? Yeah.
That looks perfect.
All right. Ta-da. All right, y'all.
That looks good.
That's how we're going to do it.
Yeah, solid core wire, so you'll be able to have a nice connection in there.
Cool. All right. Okay, so we're going to be on kit 2. Okay. And so, anyone who's just now clicking through on GitHub, you'll click Kit 2. And then where does everyone need to be following?
For Kit
there we go.
2? Okay.
Yeah, just under the table of contents, it should be the first step, which is we're going to connect So we're going to take our breadboard and kind of start on the, like, it could either be the left or the right, depending on how it's oriented. But like the numbers where it's like 60, we want to start connecting ground to ground across the board and then power to power across the board. And the only reason why the like orientation of the board matters here is that like we're going to connect all these things together in the end. And so like, it matters like which orientation we're going to go, or else we're going to have like wires sprawled everywhere, which is fine too, but you know.
Probably a likely outcome over here, but hopefully not. Okay. I don't know why all these, we got to do some engineering on these cameras. They are not staying in focus. And I don't know if it's because it's not right above it. Let's see. How's that? It's a little blurry, y'all. I'm sorry.
Once you start working with it, it should refocus.
I don't know. Okay. So, do we need a wire for this? First step.
Yes, and ideally, if we want to do the colors right, we would have one black and one red.
Ooh, okay. Let's do it. And so where am I connecting again?
So it would be from like ground to ground, just across the board. We're just going like, and then power to power across the board.
Okay, and so if we're going to be, didn't they kind of go like in that YouTube video on how to measure where to strip the wire? It was something
like
the
one that I watched, the guy was like super exact about it and even had like a ruler and stuff, and so I would say we don't need that.
Yeah, we would never finish the project. I'm just gonna guesstimate here. And then let's see. Hopefully this works. Okay. So y'all had fun. Jide, you did this kit this weekend?
Yes, I did.
That's so fun. Okay, let's try this. I hear y'all, let's see. There we go. Okay, so we're gonna go ground to, oh y'all, look at this. Ground to ground. I overshot it just a little bit, but hey.
No, that's great. I mean, it's nice like we're doing the colors right, because I did the first one and I did the colors wrong. It's been driving me nuts ever since. So.
Oh my goodness. I love this. How cool. Awesome. Okay, ground to ground, and then we're going to go power to power?
Power to power, yeah.
Awesome. Let's do it.
And Jess, for those following along, let's make sure to call out the instruction numbers.
Ooh.
Oh, right.
Awesome, y'all. What does everyone have going on this week? What are y'all the most excited about? Nothing?
Not much.
There's actually a question in the Twitch chat on which multimeter do we use?
Oh, we're actually not using one, but we could use one.
Maybe can y'all explain to our students who are learning what that is?
It would be to measure like power output if we wanted to. Actually, I have one at home. I should check the brand of it, but you can check the voltages of various things.
Very cool. Oh, Britt.
You can also use it to check your components. So, like if you have a resistor, you can put it into maybe resistance mode.
Neat.
And check what the value of that resistor is, and even capacitors too.
Very cool.
Well, actually, Britt just mentioned in chat that it's someone's birthday this week.
It already happened, y'all. It came and went. It was yesterday. I'm pretending like it's like there's just so much to do, y'all. I was like, let's celebrate in June. You know? It's all summer. I know. We joke and I'm like, oh, it's my birthday year. We'll celebrate all year. How's that? Power to power?
It looks good to me.
Oh, yeah. Happy birthday week, Hannah. remix Happy Birthday Year. Just kidding. Awesome. And so y'all, if you're just now joining, we are building an 8-bit computer from scratch on breadboards. I'm Jenna, I'm the learner here, the one learning here, alongside the 7th and 8th grade students in Robeson County, North Carolina. We have Jessie Frazelle from Oxide Computer Company, who is leading the build of Kit 2. And we have, of course, Noone and Jide Akinyode as well, helping us out, or helping me out. Let's be honest, I need all the help I can get here. What?
So, yeah, that looks perfect, though.
Awesome.
Next, we're going to do the chips. And so if we could get out one of the 8-bit bus and then 2 of the 4-bit registers.
Okay. So we may or may not have lost our manual. So if you're building this without the manual, what are we looking for?
Yeah, Jess, if you could point out the chip numbers, I think I can start, but I think the 74LS245 is what you're looking for. Just correct me if I'm misspeaking there.
Where are we in the instructions? Sorry, y'all.
We may have lost Jess. Jess, are you there? Step 1.1.2.1.
Okay. So what am I looking for?
There's a chip. Out of the chip pile you have there,
Yep.
You're looking for a chip that on the top says 74LS245.
Oh, these are so much easier to read.
Yeah, the ones from the first kit were surprisingly dull on
74L, sorry, one more time.
74LS245.
I think I picked up I'm having to look through way more than I should have to because I moved my bins around. So, it might take me a minute. Why don't y'all, Jordan and Jide, why don't y'all tell everyone more about how y'all's careers as engineers?
Yeah, I'm happy to jump in, and it did look like we lost Jess, so I hope she'll rejoin shortly here. As far as my career in engineering, I started as an aerospace engineer at USC, studying aerospace because I thought I'd want to work on planes. Looks like Jess is back there as well.
Awesome.
I'm back. I'm sorry.
Yeah, Jess. Oh,
It's been a weird morning.
That's okay. And hey, Crazy Max Dev, Jess is back.
But yeah, I thought I'd work on planes. And then the first week of college, the Rocket Propulsion Lab came in to tell us what they were working on. And I thought, for the first time in my life, I'd work on rockets, and worked on them ever since.
Awesome.
A pretty fun entry there. How about you, Jide?
Yeah, I went to University of Cincinnati, and I started as an intern at Lockheed Martin in their robotics lab. And when I got there, I got to look at the robots, but not touch them, which was great. I learned a lot. But there I fell in love with robots, and then continued, pursuing that at NASA Johnson Space Center.
Yeah.
And fast forward to now, continuing to build robots for the ocean.
Yeah. Y'all check it out, Houston Mechatronics. They have a beautiful subsea rover. Awesome. Okay, so Jordan, one more time. I just had to flip all of my chips and everything over because I'm having to go through every single one. So what am I looking for one more time? Sorry, y'all. The instructions aren't pulling up on my computer, so I'm having to memorize what y'all say.
Go ahead,
There's a bunch of ICs, like little integrated circuits, and there should be like 2 different types. So you have like 3 of one type and a bunch of the others, and so we just need one of the 8-bit buses, which should be a bit bigger than the other one.
Okay.
And then 2 of the like kind of smaller looking ones.
Okay.
It should just be like slightly smaller.
Cool. What are the numbers again?
The numbers are 74LS173 is the 4-bit registers, and then 74LS245 is the 8-bit bus. Yeah, sorry, the numbers are so hard to read, but you have your glasses, so maybe
Oh, I know,
better.
Jess. But luckily, these are actually better to read. I mean, easier to read than the other ones. So that's good. Okay, so I have this one. And can y'all tell everyone what this does?
So which one's that one? Is that the 2, 4? Oh, it's so hard.
173 looks like.
Yeah.
Oh, 173. Okay, so that one's the 4-bit register, and so this is actually what's going to hold like our little bits. And so we have 2 of them, which makes like 2 of them together gives us 8 bits. But each of them holds like a 0 or 1, you can imagine. So like either it's on or it's off. And then what we're going to do is take the 8-bit bus and then connect all these like little bits from the 4 bits up to the bus, so that we can then send it out over to the rest of our bus, since we're going to have like 3 of these. It will make more sense as we start putting it together, hopefully.
Y'all, every time I hear bus, I think of the Magic School Bus. Do y'all remember Magic School Bus?
It's kind of like that, honestly. And one time, actually, my mom dressed up as Miss Frizzle because our last names are similar.
I love that. That's so cool. Miss Frizzle was the best.
Yeah.
All right, where are we going with this bad boy?
So we're going to put it just like a few slots in from the other side of the board. And in the middle-ish. Yeah.
And crossing both sides?
Crossing both sides, and then we want like the top of it to be like facing that closer edge.
So facing, if this is the top here,
it will face towards the right, hopefully.
So it'll be in this direction, correct?
Yes, perfect.
And a few rows in, you said? Like that?
It's up to you. Yeah, that's perfect.
Alrighty. Come on, little guy, you can do it. Good thing I have these nails. Sometimes I really have to use them. Oh my god, yeah. Crazy Max have, oh gosh, gonna break a nail here. Trust me, I'm not. These things are like, these things are strong as nails. Uh-huh. Y'all get it? Didn't. Tough as nails. Here we go. Y'all, that was such a bad joke. But I am gonna have to kind of... I'm trying not to break the little legs, but let me use my tweezies. Oh!
Nice. Even if you break a leg, I've done that before for a different project, and like we can rough it back together.
Oh no! Man down. Ugh. Here we go. Y'all bless. Ah, here. I know what's going on here. Okay. Trying again. Take 2. What a great summer color. Thanks, Britt. I actually wanted it to be more neon and was not too excited, but they normally put white underneath so that it'll show up brighter, but on camera they actually look brighter than they are in real life because they're actually peach colored. There. Ah. How's that?
That's perfect. So then we're going to take one of the 4-bit registers and hook it up like 2 slots down from that.
So am I using... Wait, what am I looking for? This?
It'll be the other chip you found.
This was my bad, actually. I thought that was the 8-bit one. So actually, if we could move that one, the one we already placed, I'm so sorry,
that's okay.
down a bit.
All good.
Because we want the 8-bit bus towards the outside, actually, where we put this one. I'm sorry.
That's okay.
After all that.
That's okay, y'all. That's okay. And is this one gonna be facing in this direction as well? Is that the right way?
Yeah, because the top's like over there. That's perfect.
Perfect. Let's go. Oh, y'all. Awkward music silence. Oh. This is like country classic. Oh, there it goes. But still. It's almost like not the piano guys. I love the piano guys. Do these need to be right next to each other, or do we want some distance here?
So I put like 2 slots in between them, and it's up to you. But not like too much, because you'll see we're gonna have all these wires connecting. So
Gotcha.
Yeah, just a couple is perfect.
But they might need a little space.
Totally.
Like that Ariana Grande song, I'ma need space. NASA. Y'all know that song?
I've heard that one before. I listen to it a lot, actually.
Yeah, that's Jordan's favorite song. He loves Ariana.
Oh, really? Nice.
I'm totally joking. I don't know. Jordan's stuck here listening to Ariana Grande. I love Ariana. And I watch a lot of true crime documentaries. And so, poor Jordan. All right.
It's not as bad as she makes it sound. It's actually quite fun.
What are we doing next?
So now we have another of the 4-bit registers, and we're going to put like 2 slots or whatever, 3 slots down from the one that we just placed.
Oh, sorry. I was thinking about my Diet Coke. Which one?
Sorry, the 4-bit registers.
So that'll be the
little one like we just
LS.
Perfect. And this one, these are just going in a row. Hey, you know what song goes with this one? And sorry, Crazy Max Dev, you're about to be introduced to how I make everything a Beyonce or Ariana Grande song. But I'm like, okay, ladies, now let's get in formation.
I've heard that one before, too.
Yeah. Our chip ladies. Did y'all know that me and Jordan have a nickname for each other? Where we call each other lady. So I'll go, hey lady, and he'll go, hey lady.
That's awesome.
It's funny. It like started as, I don't know how we started doing that. Jordan, do you know? Hey lady.
I don't remember the origination of it.
Jordan's like, don't tell people that.
Yeah, we can talk after.
Let's see, y'all. What's going on here?
They come shipped like not the right angle, so it's like
what's going on here?
You have to shove them down sometimes. Like sometimes I place it like horizontally on a flat surface and then like push the little prongs down. But
oh, good idea.
Jess, when you said shove them down, it sounded much more aggressive than the delicate moving of the pins.
Yeah, no, I sorry. This is how, of course, I got in the situation where I broke one off.
Oh no! How's that?
Nice. That's perfect.
Yay.
So we've actually completed step 1.1.2. So now we can move on to step 1.1.3 and we can place our LEDs. And we're kind of doing this in a weird order, but I wanted to get like the big objects down and then do the wiring.
I like it. I like how you think. Let's do it.
So the purpose of the LEDs is going to show like if the bit is actually like on or off. So if it's on, it will be lit, and if it's off, it won't be lit. And so what we do is we connect each of like the bits on the registers that we have to the LEDs. And so we want the leg of the LED that's ground to be in the ground slot, and then the leg that is power, or the positive end, to be lined up with the actual like register of the 4-bit register. So we're gonna go from ground to pin 3 of either the first or the second, is up to you, of the 4-bit registers. So if we take one of the LEDs,
what color LED should we use?
I used red for the first 2 boards, and then I just did what Ben Eater did, but I feel like there was a purpose to it, but I'm not sure yet.
Let's do it. Okay, so and y'all remember on the LED, the longer leg is positive because positivity takes you further, right? Am I right?
That is
right. You
right.
can tell one leg is a little bit longer than the other. So we're gonna go from and I assume since we're facing a different direction, where would 1 be?
Yeah, so 1 is gonna be like the top and then the left. So like
here.
yeah, perfect.
So
yeah, and that's
1, 2, 3, 4, 5, like that.
Totally.
Awesome.
But we're gonna do it for the registers instead.
Perfect.
But it's the same thing, yeah.
And so the long leg goes in power, and then the short leg goes into
ground. And so we'll just kind of like bridge that gap between ground and like the first row, like row A there. Okay. And so we're gonna go from the 3rd pin of the first 4-bit register to ground.
So 1, 2, 3.
Perfect.
We're going here.
And then and we want like that A slot to ground basically.
What's the A slot?
Yeah, I don't.
Sorry, the A slot is the A slot of the breadboard.
I see it. So A is over here. I was like, where's A?
Yeah, I was mostly saying that because you'll see we're gonna have a bunch of these wires that overlap, and so like we need these out of the way.
So where do the legs go again?
So from pin 3 to ground, and so I think it'll be like a 17 to ground maybe. Yeah. I can't tell exactly.
And so the long leg will go in 17.
Yeah.
Like that.
And you're going to see these get super smushed together too. Yeah. Okay. And then the other one goes in ground.
Okay. Let's do it. Ooh. Even the LED looks a little more neon on camera than it actually is. Yes! LED. Edwin. We're doing it.
Sweet. So we have 4 more of these for each of the bits. And so all the pins kind of line up, as you can imagine. So we're going to go from like pin 4 now. So if you just like move down a slot and place another LED there from positive to ground.
Okay, cool. We can do that. So we're just now more formations.
Yeah, this kit has a lot of repetition, as we'll see.
That's fun. I like it. How's that looking?
That's perfect. It gets harder and harder to place these, so we have 2 more.
Okay.
Continuing down the line.
All right. What song do y'all think of? I'm still on Beyonce. Anyone else?
I still have that stuck in my head.
Oh, sorry. Sorry, y'all.
No, it's good.
Or the ants go marching one by one. How's that?
Perfect.
Edwin, how?
And then we have 1 more for this little circuit, for this little like chip thing.
Cute. Alrighty.
Just a heads up, we have about 3 minutes left today.
Okay. How did we do? What was our stop goal for today?
This was actually my goal.
Oh, perfect.
So this worked out actually.
So we're going more. How's that?
That's perfect. And then we have we have the other register, the same exact thing.
Oh, I can probably get those in really quickly. And it's the same, starting at the 3rd?
Starting at 3 and then going down for 4.
Perfect. Yeah. Let's do it. So here we go. 1, 2, 3. Bam.
Nice.
Oh, yeah. Still red? Is that okay?
Yeah, red's perfect. I mean, that's what I did. That's what Ben Eater did. So I feel like,
it.
there was a method to his madness.
I like it. Yeah. Boom. Y'all, whoa.
Nice.
Let's go. Ah! Oh, whoops. I have LEDs everywhere. Oh, yeah. I actually really like these jumpers like this, actually. I like it better DIYing the jumpers.
It's nice. It feels like, you're like also like, how when you have to like eat something and it takes works to eat it like a peanut or a pistachio?
Oh,
like,
yeah.
It's the same thing.
Oh, y'all. I would give anything for boiled peanuts right now.
Ooh.
Oh my gosh, yum. Boiled peanuts, y'all. Nothing like going to a football game, getting some boiled peanuts. Or just going, any gas station in the South, any good gas station in the South has boiled peanuts. And so you just, it's the best. But y'all, our gas stations in Alabama were, and I think still are, amazing. And we had really good food at our gas stations. And they would have these little diners attached to them. We also had pharmacies, shout out to Green Valley Drugs, who still had their wraparound bar counters. And they were little diners. So good. Oh, whoa, y'all, look at that. How's that?
That looks really good.
That's perfect. That's perfect.
Cool, make it blink, Edwin says.
Soon. It will be really cool when we load the data, honestly.
Oh, that's going to be fun. Yeah, I think we're at a good stopping point. What do y'all think?
That looks really good to me as a stopping point.
Awesome.
Me too, yeah.
As well.
Well, y'all, thanks, everybody. This was fun. And Edwin and everyone else who joined as, I assume, potentially first-timers, let us know if y'all have any ideas or suggestions with how we can make this a more impactful experience for everyone tuning in live. But we will see y'all again on Thursday. We do this live every Tuesday and Thursday at 10 a.m. Pacific. And again, we are in collaboration with the Mentor Project and Robeson County Schools, the 7th and 8th graders. So thank you, Jide, Jess, Jordan. This was super fun. I'll see everyone back on Thursday. Y'all have a great week.
Thank you.
Thank you, Jenna.
Thanks, y'all.
Thank you.
Aw, thank you.